Welcome back. Imagine you've just inherited a world-class garage, where every wall is lined with specialized tools. You have everything you need to build a masterpiece. But here's the problem I see in top-tier labs: researchers trying to loosen a critical bolt with a hammer. In mass spectrometry, brilliant people often treat chromatography as a one-size-fits-all solution. They use a $1.5 million instrument, but shove a messy biological soup through a standard C18 column and wonder why the data looks like a Rorschach test. Today, we change that mindset. The difference between a pro and an amateur isn't just running a column. It's knowing which specific tool to select before the sample ever touches the mass spectrometer. Let's get the right tools for your belt. Here is the core insight. We don't separate molecules just to make pretty peaks. We do it because molecules have different personalities. If you treat a high-charge protein like a greasy lipid, you will fail. Think of this as your separation tool belt. Some molecules are defined by their stickiness to surfaces, others by their electrical charge, some by their physical waistline or size, and others by their social circles or biological affinities. Today we will conduct 4 specialist interviews: TLC for the quick screen, IEX for magnetic personalities, SEC for the obstacle course, and affinity for the molecular handshake. By the end, you'll be orchestrating separations, not just running samples. Before we open the toolbox, let's define success. I'm here to give you a competitive advantage. First, we will master thin layer chromatography, the first date of chemistry, to stop wasting expensive HPLC time. Second, we'll dive into ion exchange, or IEX, to use molecular charge to your advantage. Third, we'll tackle size exclusion, where the biggest athletes actually finish first. Finally, we'll reach the gold standard, affinity chromatography, including how to cheat using protein tags to create a handshake. Most importantly, we'll answer the million-dollar question: how do these modes play with your mass spectrometer? Here is your team. TLC is your first impression, a quick screen to see if the investigation is worth continuing. IEX is separation by personality, looking at how molecules feel electrically. SEC is the obstacle course, using pure physics to sort by physical waistline. Finally, affinity is the soulmate level connection, the most specific tool you have. Understanding the mechanics of these 4 will allow you to solve 95% of the separation challenges you'll encounter in the field. Let's start with the first impression. Before committing to a multi-hour HPLC run, you need a vibe check. That's thin layer chromatography, or TLC. It's like a first date: fast, cheap, and tells you if there's chemistry worth pursuing. We use an inert substrate, like glass, coated with an adsorbent, like silica gel. A tiny spot of your mixture rises via capillary action. My pro tip: if you can't get a clean separation on a 50-cent TLC plate, do not inject that sample into your $500 analytical column. TLC tells you which solvents to use, and if your sample is pure enough for the next level. We quantify this using the RF value. In science, if you can't measure it, you don't know it. For TLC, we use the retention factor, or RF. This is a simple ratio. RF equals the distance traveled by the sample, divided by the distance traveled by the solvent. If your RF is 0.1, your molecule is a homebody, glued to the stationary phase. If it's 0.9, it's a traveler zipping toward the top. For a good separation, we want different RF values. This ratio helps you decide if your mobile phase is too strong or too weak. We generally look for the Goldilocks zone between 0.3 and 0.7. What if your molecules are defined by internal energy rather than stickiness? Welcome to ion exchange chromatography, or IEX. I call this separation by personality. We are looking exclusively at charge interaction. The stationary phase is packed with ionic functional groups. Think of them as tiny magnets. If you have a negatively charged analyte and a positively charged anion exchanger, they will bind. Molecules with neutral or similar charges experience ion exclusion and fly through the column. You control this race by changing the salt concentration or the pH of your eluent, essentially negotiating with the molecules to let go of the magnets. This next one is my favorite because the physics are counterintuitive. In most races, the small win, but in size exclusion chromatography, the big guys win every time. Think of SEC as a marathon through a maze of porous beads. The big molecules are too large for the pores. They take the expressway between the beads and finish first. The small molecules wander into every single pore, traveling a much longer distance. As a result, particles are separated in decreasing order of size. If you're separating a large virus from small protein fragments, this is your go-to tool. If TLC is a first date, affinity chromatography is a soulmate level connection. This is the gold standard because it relies on highly specific biological interactions, like the lock and key mechanism of an antibody and antigen. We decorate the stationary phase with a specific lock. When you run a messy mixture through, only the specific key will bind. Everything else is washed away. We then change the conditions, like pH or salt, to break the handshake and release the purified protein. It's incredibly powerful, but you must know exactly what you are looking for. If your protein doesn't have a natural handshake partner, you can cheat using protein tags. We genetically graft peptide sequences onto proteins to give them a handle. The most famous is the His tag, 6 histidines that bind to nickel. We also use MBP for solubility or FLAG for antibody binding. But a consultant's warning: every tag increases molecular weight. A His tag adds about 1 kilodalton. There's always a risk the tag might compromise the protein's native function. Be strategic and consider using a linker, like a string of glycines, to keep the tag from interfering with the active site. Now for the million-dollar question: which tools work with mass spectrometry? In the real world, HPLC and UHPLC are the bread and butter because they use volatile solvents like acetonitrile or methanol. Modes like IEX and SEC often require high salt buffers. Salt is the mortal enemy of the mass spectrometer. It clogs the source and suppresses your signal. We typically use IEX and SEC as preparative steps to clean the sample, then desalt it before moving to an analytical HPLC-MS run. Understanding this workflow is what makes you a professional analyst. We've covered a lot of ground. You now have a complete tool belt. TLC for the vibe check, IEX for charge personality, SEC for the size-based obstacle course, and affinity with protein tags for high-purity work. Remember, we don't separate molecules because we hate complexity. We separate them because we want to see the truth. In mass spectrometry, the truth of your data is only as good as the separation before it. You should now feel confident choosing the right wrench for any sample. You aren't just running a machine, you are orchestrating discovery. But knowing the tool is only half the battle. What happens when we take these modes, shrink the columns to the width of a human hair, and crank the pressure up to 15,000 psi? In our next unit, Inside the Black Box, we move from theory to high-performance reality. We'll look at how to turn these separation modes into the ultra-sharp peaks that define world-class mass spectrometry. I'll see you there.